So 7.5, further exploration with radicals, but it really is just the Pythagorean theorem. Now, if you don't know what the Pythagorean theorem is, that's okay. But just so you do know, math people geek out about this Pythagorean theorem business. So a little bit of history on Pythagoras, at least according to stories, is Pythagoras was like the master nerd back in, I think it was ancient Greece. And he liked his triangles. He liked them a lot. And, you know, when you don't have much to do on a Saturday night, like play Call of Duty, you would also like to mess around with triangles as well. But Pythagoras, being like the king nerd of his time, people were like, yeah, let's go to Pythagoras in his meetings and stuff. And he had quite a bit of a following. They kind of created a little bit of a secret society too, which the government at the time didn't like. Yeah, but it was a little bit more than math as well. So look it up. But in any case, what happens, because there's a lot of people following Pythagoras, and so what happens when you have a lot of power and you get a lot of people following you and you start making things up, right? Well, what happened was there was a guy that came to Pythagoras and he's like, I disagree with this, and it was on square roots, by the way, so it's applicable. And Pythagoras was like, you disagree with me and I have lots of power, and what do you do with people that disagree with you and you have lots of power? You kill them. So he did. He took the guy and drowned him, and they felt good about themselves afterwards. Anyway, so yeah, just be careful out there anyway. Especially with math nerds. Don't mess around with their square roots, triangles, or circles. This can be dangerous, all right? So in any case, the Pythagorean theorem, which it actually predates Pythagoras in ancient Greece. The Egyptians used it as well, but Pythagoras was, we want to remember him and him, I guess, killing people. Either way. Yeah, well, hopefully not with him in his secret society too. Okay, so this is a right triangle. Now, we'd usually show that this is a right triangle with this little mark right here. Well, that's kind of a crappy mark, but it's supposed to be like a square right there. This would indicate that this is 90 degrees. Now, don't worry about degrees. This is not trigonometry class. Just understand that right triangles have one right angle, which means that angle is 90 degrees. This 90-degree angle is made up by two sides of the triangle, which you can see are what we call legs. So this is a leg and this is a leg. Are they the same value? No. Every once in a while they will be. And then the side that doesn't make up the right angle, because there's only three sides, right? Two make up the angle, the 90-degree angle, and then this other one right here, the hypotenuse, doesn't. Okay, so the hypotenuse is the longest side of a right triangle automatically, no matter what. And that's kind of a strange word, and I think I spelled that correct, but I also don't care if I did. Just if you're like, I really want to remember this stuff, like the hypotenuse, just look up Key and Peele, and they have a nice skit about it. Okay. Yeah, they got one. So now something unique happens with the legs, the two legs, and the hypotenuse. Is if you make squares out of the two legs and you make a square out of the hypotenuse, what happens is if you take the two legs as squares and add them together, like the area, then you end up with the area of the hypotenuse. And this will happen with all right triangles. So we end up with this formula right here. You take the leg and square it, and you take the other leg and square it. So by the order of operations, you'd have to square those, and then you'd add them together, and you will have the same area of the hypotenuse as a square, okay? Now, that doesn't sound nerdy enough, right? It's like, hey, you take the leg squared and add the other leg, the sum of the legs squared, and then you get the hypotenuse squared, right? So what do they do to make it really nerdy? They said a squared plus b squared equals c squared. Now it sounds really nerdy, right? So if you've heard this before, a squared plus b squared equals c squared, that's the Pythagorean theorem, but it's based on the two legs and the hypotenuse. I kind of like to stick to the legs and the hypotenuse just so we can get the vocabulary down. And then after the final next week, you'll probably forget it forever. But whatever. All right, we just got to remember this for the final. I guess and the quiz too. So, this is an equal sign, by the way. So of course, one of these is going to be missing, and sometimes they'll say, yeah, you know what? Instead of this being an a, it'll be like an x plus 2. Well, you still got to square it, so that'll be like a quadratic with the trinomial. And then you'll have to use principles of equality to solve it, and possibly factoring as well, possibly. Oh man, I thought we were done with factoring. It's the last lesson of the whole class. We got to do factoring again? Well, it's going to be on the final exam, I guarantee it. So be ready for that, okay? So here we are. Here is a right triangle. Now I'm color coding this, just so we can remember. And if it helps you to remember that those are two legs, you know, just put that right angle in there. I mean, I don't think they show these on the assignment, if I remember right. But what do we got? Well, let's go back. So it should be a leg squared plus the other leg squared should be the hypotenuse as a square. Now, it doesn't matter the order that you put the legs in. We just know that they're both legs. Okay, they both make up the right angle. So one of them is 14, and the other one is 10. So we're going to square both legs, add them together, and we should get a hypotenuse as a square. Now remember, we don't want the hypotenuse as a square. We only want the side length of that square. That's the actual hypotenuse. So when we get to the end, once we get this all evaluated over here, then we can square root both sides and have just the hypotenuse. Well, I know what 10 squared is, but
Is it 196?
I'm going to just double check. Yes, it is. Yes, it is. So 14 to the power of 2. 14 times 14 is going to give us 196. 10 times 10, that's one I can do that one. But we're going to add those together. And again, this is going to be the hypotenuse squared, not the hypotenuse. And now we're ready to add these two together. And, well, it's not too bad either. 296 now is still the hypotenuse as a square. The last thing I need to do to get just the hypotenuse, since I have a square for my hypotenuse, I'm just going to square root both sides. Okay, so the square root and the square exponent are going to undo each other. And the square root of 296, my calculator knows what that is. 2 square root 296. So this is what my calculator says. It says 2 square root of 74. This would be what we would consider the exact value. And it may ask for it sometime, so just be aware. Again, I'm forgetting on the assignment if it wants the exact value. And let's see, it didn't give us any units on those, so we're not going to worry about labeling these. But I want that decimal, right? Because it said round your answer to the nearest hundredth. So I just pushed my double arrow button in the bottom right, just above the enter button, and it gives me this number instead. 17.20465 and some change. There's more than that, but let's just keep it there because we just need to round this to the nearest hundredth, which is the 0. So that's 2 decimal places. The 4 is going to keep the 0, 0. So we'll just say our final answer rounded to the nearest hundredth, 17.20. And I don't know that you really need the 0 there, but that's the approximate length of the hypotenuse that we've now rounded. And that's it. So we'll find the length of this one. Again, no units on this one. If they did have units, would make sure to label on our answer. But it appears that our right angle would be here. And of course, they're not going to do any funny business like, hey, this is not, this is a leg or something like that. But what we have is a missing leg right here. Oh no, that sounds kind of bad. A leg that's a value we don't know. So we're going to say we got the two legs of x and 10. But this time we have a hypotenuse value of 15. So, of course, we can solve this. It's just we're going to have to use more principles of equality to solve it. So we're going to, the square of the legs added together is going to equal the hypotenuse as a square. And evaluating these, 10 to the power of 2 is going to give us 100. I guess we've seen that one already. And 15 to the power of 2, 225, I believe. So now, here's what I got. I got x squared plus 100 equals 225. So again, hopefully we look at this and think, that's not too bad to solve. So let's continue then. Principles of equality. Let's zero out that 100. So minus 100 from both sides. We'll zero that out. And so on the left side, I'm left with the x squared. which now appears to equal 125. So I'm going to need a calculator for this one too. But at this point, to get rid of that square, I'm going to square root the x squared. But if I do it to one side, I must do it to the other side. And that will leave me with just a regular x equals, so in my calculator, square root 125, enter, which gives me, again, this is the exact answer, 5 square root of 5. But we did want the decimal because it said round to the nearest tenth. So again, just at the bottom right of the calculator, push that double arrow button, and I got 11.180.33989. Now, I'm only going to go to the 0 because we only need 2 decimal places. The nearest, oh, this one is the 10th. So I did that kind of wrong there. But the 1, so I look to the right. That 8 is 5 or more, so we're going to add 1 to the 1 in the 10th place value, which gives us a 2. We end up with x equals 11.2. And that appears to be our final answer here. Rounded anyways. Given a field 159 feet by 65 feet, how far is it to walk from one corner of the field to the opposite corner to the closest tenth of a foot? Now, of course, we know, since we're in applications of that, whatever the crap they call it, we're going to be using the Pythagorean theorem here, okay? So think about this. And if it helps you to draw a picture, do it, right? Because we know it's a field, so we should be expecting some kind of rectangle at this point. Yeah, but that's not a triangle right there. Well, let's take a look. I'm just going to set this up, and then I'm going to give you a chance to finish it off. Okay, so 159 feet by 65 feet. And these ones are labeled, so we'll make sure that we label our answer. But from here, if you need to reread the problem, do it, and see if you can set this up so that you can solve it as well. And then we'll go over it, okay? Take a minute to do that. Well, if you felt confused on this one, that's okay. But let's go over this so that hopefully you feel a little bit better about it. So remember, it said you're walking from one corner of the field to the opposite corner. So that'd be like starting maybe in the top left and going to the bottom right of that field. Which now, if we get rid of a little bit here, hopefully we can see this now will create a right triangle. Which is, it's just kind of how all triangles are. They're just kind of like half of a, well, parallelogram, but rectangles as well. And now we have this right angle right here, which gives us this right triangle. So we can see that we're dealing with two legs in this case. One of them is 65 feet. The other one is 159 feet. Why isn't it 159 and 65? Because it doesn't matter. So we're going to take the squares of these and add them together, which is going to give us the hypotenuse as a square. So putting these into the calculator, looks like 65 squared was 4,225. And 159 squared, no, it is, 25,281. Fairly large numbers, but we can still deal with those. So again, this is going to be the hypotenuse as a square, and then we can add these two together. Which is going to give us 29,506. Well, this is the hypotenuse as a square. So we just want the hypotenuse, though, not the hypotenuse as a square. So, of course, at this point, we're going to square root the hypotenuse. But if I square root one side, I must square root the other side. And the good news is, when I put this into the calculator, it actually just gave me a decimal. So this is the decimal it gave me, 171.7731062. But it did say it round to the nearest tenth of a foot. So that's the first decimal place value. The one to the right is 5 or more. So we're going to add 1 to that 7, making our final answer rounded, 171.8. And this is where we do need a label. It's just a length, so it's just going to be in feet. And again, this is the hypotenuse. Not the hypotenuse is a square, but the hypotenuse. There we go. So a 12-foot ladder is placed against a building. If the base of the ladder is 3 feet away from the building, how far up the building will the ladder reach? So don't, it's not usually good to climb up a ladder where the end is right up against the building, but whatever. That's kind of what they want on this. So round the answer to the nearest tenth of a foot. Okay, so let's draw this out, see if we can use some technology. So this is a building right here, and then we're going to take a ladder. Let's see, a ladder, and lean it against the building. And then, of course, at the bottom here, you'd have the ground. Something like this, okay? So the purple's the ladder, we got the building in black, and then the ground that's green. And then they say, well, it's a 12-foot ladder. Okay, so this is 12 feet right here. And the ladder, the base of the ladder is 3 feet away from the building. So that's this distance right here, 3 feet. So what we're missing is the height of the building. How far up the building will the ladder reach? So this is the setup. And hopefully we see at this point that we have a right angle right here between the ground and the building. Hopefully it's a right angle. But again, if you're like, yeah, but no one would really put if they're going to climb all the way up onto the top of this roof, that they're going to put the end of the ladder right here, because if there's soffits or something like that, then it could fall in there and then you injure yourself. That's no good. Don't worry about it. Don't make it overcomplicated, okay? So now that we got that set up, let's go ahead and take a look at our Pythagorean theorem. And in this setup is the a leg or a hypotenuse? It's a leg. Is the 12 a leg or a hypotenuse? It's a hypotenuse. We're going to make a 12 right there. Okay, so we're going to take 3 squared plus the other leg as a square should equal the hypotenuse as a square. Now, I put leg right there. If you said, yeah, but you used x over here, and shouldn't you use x right here? You can. It doesn't matter. It means the same thing. They're both variables. We don't know what they are yet. So let's go ahead and put this in. So 3 squared is going to give us 9. 12 squared, that's 12 squared is 144. So now I got 9 plus the leg squared equals 144. Continuing to solve. Let's go and subtract 9 from both sides. That'll be 135 there. Zero that out. Now I've just got a leg squared equals 135. So of course, to get rid of that square, we're going to square root both sides. And this will leave us with the leg. And yeah, we'll just put this in the calculator. Square root 135, enter. Oh, here it is again. It says your leg exactly is 3 times the square root of 15. And of course, this would be in feet. So this would be the exact answer, but they did say, please round this to the nearest tenth. No problem. So double arrow button above my enter button, and it gives me the decimal. So this would have gave me 11.618. And I only wanted to the nearest tenth, so I don't really need any more. Of course, this is going to be in feet. So let's see, the tenth is the 6, to the right is a 1. So it will remain a 6. So the final leg here is 11.6 feet. So that building would be, assuming that the ladder goes to the very top, is 11.6 feet tall, or that 12-foot ladder is reaching 11.6 feet high. You decide. Solve for x. Well, there's lots of x's. And we got some relationships going on here, right? Like, here's this leg, and, well, this one's 7, I guess, units longer, and this one is 14 units longer. Let's see how this plays out. So once again, we're just going to go back to our Pythagorean theorem, and we have values to work with, so that's nice. Okay, so there's our Pythagorean theorem. we have the legs of x, and also x plus 7. So that's a binomial that we're going to have to square, by the way. Then the hypotenuse, which is going to be the leg. This looks like the shortest leg, but 14 more than it. So as I square this one, as I square the first x, not too bad, it's just squared. But as I square the second leg, which is x plus 7, I'm going to want to show this in parentheses and square it. And it will equal the hypotenuse also in parentheses, which I'm going to square also. Okay? I don't know, not really so fun, but we'll make it work. So let's take a look first at our x plus 7. So remember, x plus 7 squared is like taking x plus 7 and multiplying it by x plus 7. This does not mean that you'd have x squared plus 49. That's not what it means. You've got to square everything on the inside of that parentheses right there. So it's x plus 7 times x plus 7. So x times x is going to be x squared. X times 7 would be 7x's. And then another 7 times x is 7x's. And then we got 7 times 7, which is positive 49. Simplifying these, my 7x's right there, gives me x squared plus 14x's plus 49. Now that's just from the x plus 7 squared. Now let's look at the x plus 14 times x plus 14. Okay, so I got x times x, which is x squared. Then I got x times 14, which is 14x's. Then I got 14 times x, which is 14x's. And 14 times 14, which my calculator tells me is 196. Yeah, I forgot what it was. Yeah, sorry. And then 14x's plus 14x's is 28x's. So now I've got x squared plus 28x's plus 196. Okay, so that's just the simplification, or I guess just the expanded form of those squares. But what else did I have? Well, remember I have the other leg, which is just x squared. And then I'm going to have to add that other x squared plus 14x plus 49, and that's going to equal, now that I've got the x plus 14 squared, as the trinomial quadratic right there. But here, I still have two like terms that I can combine. I can take these x squareds. There's one x squared plus another x squared, which is 2x squared. And that just simplifies that part. So we're just left with the rest of this. I don't know, that kind of looks like garbage to me. But remember, this is now going back to what we have with factoring. Now, I'm not going to factor yet, but I know that I should, since I've got a trinomial, I want it to equal 0. And then once I factor it, then I can just set both the factors equal to 0, as long as it works out nice and pretty. So that's what we're going to do. So I'm going to make the right side equal to 0. So the first x squared, I'm going to subtract x squared from both sides. Really, it's a 1x squared. So minus a 1x squared there is going to leave me with a regular 1x squared, but we'll just make that a phantom 1 right there. And then the 28x's, we're going to zero that out. So minus 28x's. Minus 28x's can give us negative 14x's. And then also minus 196 from both sides. I'll go to my calculator for this one. 49 minus 196, enter, negative 147. Yeesh. Oh, okay. Well, dang it. That is going to factor. Okay, and what is this going to equal? Well, all three of our terms zeroed out, so this is what we wanted. We want it to equal 0. And since we like factoring so much, here we are again. So let's take that. It's a negative 147. It's not divisible by 2, but it is divisible by 3. How do I know it's divisible by 3? Because 1 plus 4 is 5, plus 7 is 12. And so, what the heck, 147 divided by 3. Just put in the calculator 49. Okay, well, that's not going to get me to 14, but since I see the 49, I know another factor pair is going to include 7. So 147 divided by 7 is going to give me 21. There it is. Let's see. Looks like, well, I don't see that any of the other factor pairs would work. But now we need this to be negative 147, so one of these has to be negative. And when we add them together, it should be negative 14. So it looks like it's going to be the negative 21. Okay, so that means if you were to take the 7 and add negative 21, you'll get the negative 14 middle coefficient right there. Now our leading coefficient is a phantom 1, so going back, this means that we can split it right now into the two binomials. We don't have to worry about factoring by grouping, but you're welcome to in case you really like it so much. And yet this still equals 0. Okay, but our two factors were a positive 7 and a negative 21. Now, I think some of you guys may not need the rest of the work to show this, but we're going to do it anyways. Let's see what happens with a little bit more space. So we're going to say, let this, let's take this x plus 7, and if I could get it to equal 0, then I would get a true statement there. So minus 7 from both sides. That's going to zero out. Looks like x would be negative 7. Now, right, so we said in the last section, if you get solutions to these types of problems, make sure you check. And so we're going to eventually check. But let's look at the next one. So we're going to take that x minus 21. And if I could get this to equal 0, then it would still be a true statement. So add 21 to both sides, and we get x equals positive 21. Okay, so in checking, just in checking, okay, and I'm not even going to check up here, and the reason is because if I said this x is negative 7, I mean, that seems kind of jacked up if you said, hey, the length of this triangle, the side length of this triangle is negative 7. That's kind of weird. In addition to that, what's 7 more than negative 7? It makes this side 0. Well, that's garbage. So clearly negative 7 is not going to work. Now, if you went up here and said, well, what about negative 7? Is that going to make this work? It does. You should get a true statement up here, but again, in the context of the triangle, no good, because that means this side length is 0. So we know that negative 7 is not going to do us any good. So let's try the 21. Let's see. If we got 21, then this side would be 21. This one would be 28. And this side length would be 35. Okay. Well, let's see if that works in our calculator. So what I'm going to do is I'm going to take the two legs of 21 and 28. Seems kind of off to me, but let's find out for sure. And if we square the two legs, add them together, then we should get the 35 as a square. So 21 squared plus 28 squared. I'm just putting this directly into my calculator. And this is, the left side is 1,225. And then 35 squared, enter. It is, it's the same, 1,225. That's a 5. So this ends up showing that we have a true statement with these values. I don't know. Yeah, they shouldn't want any negative values on this, so we're just going to say this one. X is 21. Yeah, they didn't give units on that, so we'll just say, I guess, yeah, X is 21. Solve for X, that's what it said originally. So find the unknown length. And yeah, spoiler alert, I got 6, but let's make sure. So with our Pythagorean theorem, we have a hypotenuse, which is already showing as a square root of 157. Now that's going to be convenient because, of course, we're going to square that. And we have the two legs of A and 11, which we're going to square these as well and add them together. So 11 squared is going to be 121. And again, the square root of 157, but if we square it, then it gets rid of the square root. So we end up with just a regular 157 right here. Okay, so now I've got a squared plus 121 equals 157. And continuing to solve now, we'll subtract 121 from both sides. zeroing that out, isolating the a squared, which we do want, isolated. A squared now equals, this gave me 36. And then we'll square root both sides to get the final a, which appears to be 6. Okay, now again, if you're thinking, well, wouldn't negative 6 work? It will make it true, but again, in terms of lengths on a triangle, you wouldn't want to say, we got a negative 6 length on there. It's labeled as well, right? At least the one side length. This one should be labeled. So, of course, it's not 6. The answer is not 6, but 6 centimeters. That looks better. Okay, so, yeah, and again, we can check. 6 squared is 36, plus 11 squared is 121. 36 plus 121 is 157. But again, that would be the hypotenuse squared, so you'd square root that in order to get the actual side length of that hypotenuse. So it just ends up being the square root of 157, it looks like. So that's good.